Imagine a world where robots anticipate needs, learn from videos, and navigate crowds with grace. This episode explores the robotics revolution through adaptive machines, synthesizing 54 papers from Computer Science Robotics, dated between November 18th and 19th, 2025. This presentation weaves a narrative from 54 papers, blending technical insights with engaging stories. Patterns in adaptive robots are uncovered, from kitchen helpers to surgical aids. Breakthroughs are set to make machines intuitive partners in daily life. The content is aimed at all audiences, from newcomers to experts, to inspire curiosity about embodied AI. Computer Science Robotics focuses on designing intelligent machines that interact with the physical world. Algorithms, sensors, and AI are fused for perception, decision-making, and action. Key applications include self-driving cars, surgical bots, and exploratory drones. Challenges such as sim-to-real gaps are addressed for reliable, real-world performance. Efficiency in manufacturing, safety in hazardous environments, and personalized healthcare are promised. A prominent theme involves adaptive human-robot collaboration, where robots adjust to changing human goals without explicit commands. For example, Ghose et al. Enable robots to detect mid-task shifts in cooking scenarios. Adya et al. Synchronize robot movements to human heartbeats for artistic collaboration. Empathy in machines is emphasized for dynamic settings, like homes or factories. Intuitive teamwork is built, reducing the need for constant human oversight. Another key theme centers on advanced motion planning and control in dynamic environments, addressing navigation through clutter or crowds. Nakao et al. Employ winding numbers to break symmetry in multi-agent paths, avoiding deadlocks. De Meyer et al. Utilize multi-agent reinforcement learning for deadlock-free movement. Robots are taught traffic rules for unpredictable scenarios. This is crucial for warehouses and autonomous fleets. Introducing topological methods for navigation, learning-based policies for perception and manipulation are dominant, leveraging AI to teach robots from data. Kai et al. Scale egocentric videos for language-conditioned grasping. Fei et al. Optimize vision-language action models with self-referential rewards, boosting success from 49% to 99% in benchmarks. The need for hand-coded rules is reduced. Self-supervision is explained as using the model's own data for improvement. Safety and robustness in specialized applications are emphasized, ensuring reliability in high-stakes areas. Pupala et al. Integrate quantum cryptography for nuclear plant robots. Chen et al. Develop force-aware diffusion policies for ultrasound scanning, achieving 95% success on unseen patients. Trust is built by addressing potential failures. This is key for environments where failures could be catastrophic, such as medical or infrastructure tasks. Simulation to reality transfer and scaling are frequent, closing the gap between virtual training and real deployment. He et al.'s VRIL framework enables zero-shot humanoid loco-manipulation, training on 64 GPUs for seamless real-world performance. Multimodal AI integration, like vision language models, enhances decisions. Meng et al. Benchmark VLMs for driving safety, fine-tuning to handle in-cabin and external risks. Huang et al. Use LLMs for reward disambiguation in manipulation. These themes interlink to create adaptive, intuitive robots that handle real-world uncertainties. Key findings across the papers include several game changers. Scaling data and compute yields emergent capabilities. Kai et al. Combine over 1,000 hours of egocentric videos for robust manipulation from everyday footage. Self-supervision revolutionizes efficiency. Fei et al.'s SRPO method achieves 99% success in 200 steps using self-generated rewards. Topological innovations enhance navigation. Nakayo et al. Improve multi-agent crowd navigation by 167%. Safety benchmarks expose vulnerabilities. Meng et al. Improve VLMs by over 20% with fine-tuning. Bio-inspired designs optimize energy. Gliesbauer et al. Discover efficient gates via virtual energy injection. Common methodologies across the papers include reinforcement learning, which teaches via rewards in simulations or real setups. He et al. Apply it for humanoid skills, excelling in uncertain tasks that requiring massive data. Model predictive control optimizes future actions. Nakao et al. Use it for topology-aware navigation, handling constraints well but computationally intensive. Diffusion policies generate actions from noisy data. Chen et al. Apply them for ultrasound. Modeling multimodality robustly but with slow inference. Graph-based methods handle relational data. Gao et al. Use them in subsea tasks, efficient for swarms but scaling poorly with size. Hybrids are often used to balance strengths for real-world efficiency. Ghose et al. 2025 address adaptive collaboration in their paper titled, "I've Changed My Mind, Robots Adapting to Changing Human Goals During Collaboration." This work is selected for its impact on human-robot symbiosis, enabling intuitive partnerships. The objective is to detect and adapt to goal shifts without communication. The method involves a policy bank with Bayesian inference and receding horizon planning trees. Findings show 40% faster goal convergence and 25% task time reduction. Significance lies in fostering trust in shared spaces like homes or factories. He et al. 2025 present viral visual sim-to-real at scale for humanoid loco-manipulation. This paper is chosen for its novelty in safe, scalable humanoid training. The objective is zero-shot transfer from simulation to real hardware. The method uses teacher-student reinforcement learning with domain randomization on 64 GPUs. Findings indicate successful execution of 54 cycles, reducing errors by 80%. Significance includes democratizing versatile robots for applications like disaster response. Mattille et al. 2025 advance minimally invasive precision surgery in open cavities with robotic flexible endoscopy. This work is selected for its representativeness in high-stakes medical applications. The objective is to enhance dexterity in fetal surgeries. The method features a magnetic endoscope with mosaic reconstruction and semi-autonomous modes. Findings demonstrate sub-millimeter accuracy and 30% time reduction in vivo tests. Significance extends to democratizing precision surgery and lowering complications. Future directions in robotics include deeper multimodal fusion, such as combining vision-language models with tactile sensing for smarter manipulation. Swarm intelligence is scaled for logistics through decentralized learning. Bio-inspired hardware promotes energy efficiency in remote explorations. Safety frameworks evolve to certify AI across domains. Challenges like sim-to-real gaps, computational demands, and inclusivity are addressed through interdisciplinary collaborations. This deck was synthesized using AI tools, including GPT Grok with model Grok 40709 for content generation. TTS synthesis was performed via OpenAI for audio narration. Image generation utilized Google for visual elements. A human expert reviewed the content, though potential oversights may exist. All references are provided for verification and further reading. Subscribe to the YouTube channel for more captivating AI research stories. Hit the bell for updates on the latest in artificial intelligence and robotics. The channel title is AI Frontiers. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer, this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.